Hello, this is Mr. Huber. In this lesson, we're going to look at factoring quadratic expressions. Factoring is like reversing FOIL. Factors are what would multiply together and give you the resulting product you're looking for. In this case, a quadratic expression. And oftentimes, when we factor a quadratic, we're going to end up with two binomials as our factors. So we're going to look at how that process might work. If we have a quadratic expression that looks like this, x squared plus bx plus c, where we'll say that a is a 1. We're not even going to put an a there. We're just going to start with this always being a 1. Okay. The way we factor this is look for numbers that multiply to give us c, right? We're going to look for numbers that multiply and give us the c value, and add up to give us the b value. So numbers that multiply and give c and add up to b. And we're going to use those as the second terms in each of our binomials of our factored form. So let's see some examples here. If we wanted to factor x squared plus 10x plus 24, okay, and we're looking for numbers that multiply to give us 24 and add up to 10. So to add up to a positive 10, there are going to have to be two positive numbers. To multiply to give a 24, right, two positive numbers. So when we start out by writing the factors, we can oftentimes fill in those signs. We're going to have x plus and x plus. Because again, we have to have numbers that fill in here and multiply together to give us c, and then add together to give us b. So we might need to list some factors of 24. If you wanted, you could write a whole list of them out and figure out what numbers multiply to give you 24, like 1 and 24, 2 and 12, 6 and 4, 3 and 8. We want the numbers out of those groupings, those pairs that add up to 10. In this case, we are going to have 4 and 6. And it wouldn't matter if you put the 6 first and then the 4. The two factors are x plus 4 and x plus 6. Okay? If we wanted to check that, we could FOIL this. Right? We could do x times x, that's x squared. X times 6, that's plus 6x. 4 times x is 4x. And 4 times 6 is 24. And then when we write out our final form for this, we could combine those two middle terms to give us 10x plus 24. And we can see that is in fact what we started with. So this would be the correct factored form for that trinomial. When you factor trinomials, okay, it's going to take a little trial and error, and there's some information posted that you can use to help you, a cheat sheet if you will, that talks about how to set up the binomials. So how do we know when these are going to be pluses or minuses? And what do you look for there? And then something called checking with swings. You see the swings are these two middle terms and then these two outside terms. And I'll show you some of that as well. That's how we can check and make sure that the middle here is going to work out. So use that as an extra resource to help you along the way as you're doing these problems. Let's try some here. So we have x squared plus 8x plus 12. So again, since these are both positives, and again, if you check on the cheat sheet, you're going to see that it talks about how we can make this two binomials where we would have to have a plus and a plus. Okay? And then we got to find numbers that multiply to give us 12 and add up to 8. So in this case, it would be 6 and 2. 6 and 2. And the checking with swings is right here. Look, it looks like a couple of swings. 6 times x is 6x. 2 times x is 2x. When I add these together, I get 8x. That's a way to check that my middle term is coming out correctly. So that means this is the correct factored form. Okay, that's a way to check and see if it's coming out correctly. Now let's see what happens when they're not both positives. Okay? So here in this next example, you can see plus and then a minus. So when we set up our beginnings of our factored form here in our two binomials, we're going to have x and x. But in this case, if we're multiplying to give negative 20, we have to have different signs here. We can't multiply two positives and get a negative. We can't multiply two negatives and get a negative. We need to multiply a positive and a negative. And now when we add the two middle terms together, if you will, when we're going to add the two numbers here, we're really subtracting because we're adding a positive to a negative. When we add a positive and a negative, that's like finding their difference, subtracting them. So here we're going to figure out numbers that multiply to give us 20, but subtract to give us 1, right? There's a 1 here that's not written. So factors of 20 that multiply and give us that, but add up to 1 would be 4 and 5. So let's see, where would the 4 go and where would the 5 go? Let's put the 4 here and the 5 here. It does make a difference here because they're not both positives. So when we check this with swings, we're going to get 4x minus 5x. When I add these, I get negative 1x. You'll see right here we didn't want a negative 1x. We want a positive 1x. So we could go back and fix this. Okay. The good news is if you get the right number with the wrong sign, all that means is that we need to go back up here and switch our signs in the factored form. So we could take this and make this the plus, make this the minus, and then we'd have minus 4x plus 5x. That gives us a 1x. So to write that out a little more cleanly, we'd have x minus 4 and x plus 5. Because those two numbers multiply to give us negative 20 and add up to a positive 1. And there would be n's instead of x's. So I should use the right variable there. Okay. In the next example, we get two negatives. So if I'm going to go and try to factor this, okay, when I have my two negatives here, I start to set up my factored form, and I get m and m, and I have one positive and one negative because I've got a negative 16. So now I need numbers that multiply to give me 16 and subtract and give me 6. That's going to be 2 and 8. How do I know which one's the 2 and the 8? Again, I can check with swings, or I want a positive 2 plus a negative 8 to give me this negative 6. All right? A positive 2 times a negative 8 gives me negative 16. Multiply to give me negative 16, and add that negative 8 to give me a negative 6m. Right? And again, you could FOIL that, check with swings, make sure it's working. That would be your correct answered factored form. Okay. In our next example, okay, we're going to have h and h. And since in this case it's a positive 18, we need to have the same sign here and here. But we don't want them both to be positive, because if it was plus and plus, we'd add them, we'd never get a negative 19. So we're going to have a minus and a minus. Because if I multiply two negatives, I'm going to get the positive 18. And now I need to add them together and get negative 19. This is important to remember, that when you're factoring and finding lists of factors, like 2 times 9 and 6 times 3, don't forget about 18 and 1. If you multiply 18 times 1, you'll get 18. So sometimes that is the correct factoring you want to use. In this case it is. So that would be our answer. H minus 1 and H minus 18. Okay. The minus 1 and minus 18 will multiply together and give us positive 18. They'll add together and give us the negative 19. So there you see some examples of some factoring you're going to want to practice and make sure you're up to speed with. Okay. Take a little break for some trivia. Who was the first athlete to be paid a yearly salary more than the President of the United States at that same time? So the first athlete to be paid more than the President of the United States for a year was Babe Ruth. In 1932, he was paid $80,000 by the New York Yankees, and President Hoover was paid $75,000. He was famously asked why he thought he should be paid more than the President. He said, because, quote, I had a better year. And he very, very well may have. So let's look at factoring when there's a number in front of the x squared that's not a 1. All of the problems we did so far, this a value was a 1. Now, let's say it's a 6, okay, or something else. Anything other than a 1 makes it more difficult, because when this a value is not 1, we have to take into account that there's going to be a factor in front of the two x's here. It's not just going to be 1x and 1x. For 6x squared, this could be 6 and 1. It could be 3 and 2. It could be the 1 here and the 6 here. We've got some work to do to get our factors of 1 and 6. Or excuse me, of 6. It could be 1 and 6 or 2 and 3. So we're going to see a couple methods we can use to solve where we're trying to factor and the a value is not a 1. First would be just to list the factors of 6 and 2. So our factors of 6 we can see right over here, and our factors of 2 right over here. That's our factors of 6 and of 2. Right? We want to find out what numbers we could use to go in those places in our factored form. right? So that when we write this out and we've got our two binomials here and here, we're going to have an x and an x. And in front of here, we're going to have some factors of 6. One of these pairs of factors is going to go here and here. And our factors of 2, 1, and 2, so that's kind of nice. At least we only have one option that can go here and here. Right? What we want to do is find the combination where if I multiply one of these pairs of factors together and then add them, I'll get my middle term of 7. Right? I want to find out what will still add up to give me my middle term of 7. So we could try a couple different things. Let's say you plugged in, and we'll do one that doesn't work here first, but let's say we did 6 and 1, and we know these are going to be positive, so that's a good thing there because that helps narrow it down, and 1 and 2. If you check with swings, you're going to get 1x and 12x. You add those together, you get 13x. That is not going to be the correct middle term. So we would know that this is not the factored form we're looking for. And it might take some trial and error. Again, it may take a little while to figure out which factors are going to be the right ones that work. And eventually, if you keep working it down, you should hopefully figure out that if I multiply 2 times 2, I get 4. And then if I multiply 3 times 1, I get 3. And when I add that, I'll get 7. So now I need to write that into my factors so that I get them matching up properly and multiplying the right numbers. So I want this 2x from right here to multiply this 2. So I need that to drop in over here. So when I check with swings, right, the 2x is going to multiply all the way out here with that other 2 that I wanted. So that's going to be a 2 right here. And then that means I'm going to have my 3x right here. And this is going to be my 1. So, right, 2 and 3, my factors of 6. 1 and 2, my factors of 2, where if I check with swings, and it's going to be even more important in cases like this to check with swings. That's 3x and 4x, and when I add those together I get 7x, which is the middle term I wanted. That's going to be my factored form for 6x squared plus 7x plus 2. So some trial and error there. Sometimes that's what it takes. Fill in the factors and then FOIL them, or at least check with swings and see if you're on the right track. Okay? You can use that cheat sheet, if you will, to figure out what the binomials are going to look like. Are they going to have positives, negatives, and at least get a start on how can I fill in some numbers that might work. Okay? There's another method called the AC method. It's called that because we're going to multiply A and C together and use that product to figure out what factors give us that B value. So we're going to show you that one next, and you'll be able to figure out. Pick the method you think works best for you, practice it consistently, and you'll get good at it. So in this example, we're still going to factor 6x squared plus 7x plus 2. We're going to multiply A and C, right? The AC method. Multiply A times C. We get 12. Now I want to figure out factors of 12 that add up to 7. So that would be 4 and 3. So we're going to rewrite this middle term. Instead of 7x, we're going to rewrite it as 4x and 3x. You can see that right down here. 6x squared comes straight down. The 2 doesn't change. The 7x, we figured out these are the two factors from the AC method that I can put in my middle here. It doesn't matter which one you put where. The key now is that we're going to group these together. We're going to group these first two terms together, and I'm going to factor out of that what's the greatest common factor. The greatest common factor of 6 and 4 is 2. Okay? And then I've also got an x here. X squared and x, I can factor a 2x out. When I factor 2x out of this, I'm left with 3x plus 2. Then I want to go to my second two terms here, and I want to find the common factor of 3x and 2, which is just 1. Okay? 1 is the greatest common factor there, and then I'm left with 3x plus 2. When you do this, in the parentheses here, these should be the same. If they're not, you're going to be aware that you made a mistake and know that you're not on the right track. These two should be the same binomials here and here. And so what I'm going to do is I'm going to take the 3x plus 2, and that's one of my factors. And I'm going to take the greatest common factor here, and that's my other factor. And you can see that's the same answer I got when I did that first method where I just figured out what were my factors of 6 and 2 and which ones kind of plug in and work. Checked with swings. It might be good still here to check with swings. Okay? But you're going to use that AC method to then figure out factors you can then group, pull out a greatest common factor, and figure out how to get down to here, your two factors that if you multiply these together will give you 6x squared plus 7x plus 2. Okay? So again, figure out which method you think is going to work best for you and try it out. You're going to have some examples here you should try and check and see if they're working. Okay? So 3x squared plus 8x plus 4. So let's do the AC method we just talked about and see how that one works for this example. So the AC is going to be 3 times 4, which is 12. So I want numbers that multiply and give me 12 and add up to 8. So that'd be 6 and 2, right? 6 times 2 equals 12, and 6 plus 2 equals 8. So that means I'm going to rewrite this as 3x squared plus 6x plus 2x plus 4, right? The 6 and 2 here, that are the numbers that multiply to give me 12 from the AC method and add up to 8, are going to then be my coefficients here in front of the x's. Okay? So now I want to group this. Okay? I'm going to take these two terms here, and I'm going to figure out my greatest common factor is 3x, and then I'm going to be left with x plus 2. And then I'm going to take my second grouping there, and I'm going to factor out a 2. So plus 2, and then I've got x plus 2. Right, again, these are coming out the same, x plus 2 and x plus 2. Right, if I multiply the 2 back in here, I get 2 times x is 2x, 2 times 2 is 4. 2 is a common factor of both of these, and these are the factors that are left over when I take the 2 out. Okay? So now I can write my final factored form of x plus 2 and 3x plus 2. And you could check with swings, you could FOIL it all the way back out. It's important to right here, check your answer by multiplying the binomials back together. Right? FOIL this out, or at least do the check with swings and make sure you're getting part of the answer right and that middle term working out correctly. Okay? It wouldn't be that hard to just FOIL the whole thing and make sure you're on the right track. And it'd be worth the time. Now we're going to try another one, 4r squared minus 9r plus 5. All right, so let's figure out what we can do here. Again, if we want to use that AC method, we can do AC equals 4 times 5, that's 20. In this case, if we look here at the beginning, we're going to see that when we write our factored form, we're going to have a negative and a negative, because I have to multiply and get a positive 5. That means these have to be the same sign. They're either both plus or both minus. Well, if I'm going to add the middle terms together and get negative 9, I can't add two positives and get negative 9. So that means I have to have both the same sign, both negatives here. Okay, so just keep that in mind. And so now we want to find factors of 20 that add up to 9. So factors of 20 that add up to 9 are 4 and 5. So I can rewrite this original trinomial as 4r squared minus 4r minus 5r plus 5. Again, 4 times 5 gives me the 20 and adds up to the 9. And they're negatives because they're going to still multiply and give me positive 20, but add up to negative 9. And now I can group this. So when I group this, I'm going to get 4r, and then r, that would be a minus 1. And then I'm going to factor out a negative 5. So if there's a negative sign here in front of this, you want to keep that down. When you bring it down, you're going to factor out the common factor of 5, and it would be a negative 5. So I'm going to factor out a negative 5 and be left with r minus 1. All right, negative 5 times r would be negative 5r. Negative 5 times negative 1. Negative times negative, that's how I get the positive 5. And again, these should be the same, r minus 1 and r minus 1. So now I can go back up, and I could go to those original sets of parentheses I set up for my two binomials, and I can fill these in there now. I'm going to have 4r minus 5 and r minus 1 as my two binomials. So 4r minus 5 and r minus 1. And that would be my final factored form for that trinomial 4r squared minus 9r plus 5. The quadratic gets factored down to those two binomials we see there in the parentheses. All right. One more example, and again, you should be trying these and seeing if you're on the right track for them. So in this case, again, you can pick the AC method or that first one that kind of a little more of a guess and check. I'm going to talk about that one. So my factors of 3 are 3 and 1. My factors of 4 are 1 and 4 and 2 and 2. And if I look at this here, when I go to write my factored form, I'm going to have m, and since this is a negative, I need these to be different signs. One positive, one negative. So I can fill that in right now if I want. One positive, one negative. And that means I'm going to have a positive times a negative, give me -4, and then it's going to have to subtract and give me -1. So I've got to find some combination of multiplying these together where when I subtract, I'll get -1. Okay? So what might that be? Well, if I do 3 times 2 is 6, 1 times 2 is 2. When I subtract those, I'm not going to get -1. Okay? The sets that will work are if I multiply 3 times 1, that's 3. And then I multiply 1 times 4, that's 4. When I subtract 3 minus 4, I'm going to get -1. So that means when I set these up, I'm going to have 3m and 1m. And then I'm going to have 1 and 4. But if you look at how I set this up right now, this 3 is going to multiply the 4, but up here I said I wanted the 3 to multiply the 1. So I need to switch these. You could figure that out. If I check with swings, I'm going to get 1m minus 12m. That's not going to add together and give me the -1m here. So you could go back and we could fix out, or we could figure out that we set that up wrong, and we could fix it. Okay, we can make this the 4. We'll try that again. We can make this the 4, and make this the 1. So now if I check to this with swings, okay, I'm going to get 4m minus 3m. And I'm going to get 1m. Remember, I said if we get the right number and the wrong sign, which happened, we got the right number, 1, but the wrong sign, we're going to have a -1. That means I need to go back up here and I need to switch these signs. This needs to be a negative, and this needs to be the positive. So look for that. And it's okay, that's where we check, because we could be off. Hey, we know we want to get 3 and 1 and 4 and 1 and subtract and get 1, but we're still off by a little bit because we have a positive 1m, so we can go back and fix that. It's not that difficult to do at this point, so I can take my answer here, and I'm going to take this and I'll make that a negative, and I'll make this the positive. So my final answer, I'll write it a little more cleanly here, would be 3m minus 4 and m plus 1. You could write 1 in front of the m if you want there, that's fine. That would be my final factored form. If you tried the AC method and got that same answer, that's great. Again, I'm not telling you one method is the way to go, just giving you a couple options. You figure out the one that if you practice and get good at, you're going to be able to use consistently and do well.